Good day, sir. Today we're going to present our mini project for our subject embedded control and technology. Our topic is agriculture water pump control. So myself is Commissioner Paniselvan and my other two group members is Muhammad Azim and Nur Aisha. Actually, our project based on the agriculture's using smart irrigation and monitoring system. Traditionally, irrigation tasks have been performed by farmers, which rely on their experience to determine the times and duration of crop watering. However, this type of open loop control system based on timers and lead to an under or over watering if they are not set correctly, which can result in damage of the crop and waste of water. Irrigation is the most common form of irrigation found in greenhouse operation. Is overhead irrigation by applying water to the media surface by hand watering with a hose, micro irrigation, overhead sprinklers or booms. The demand of water significantly increased in the last 40 years, leading to the depletion of renewable groundwater waterhouse. The government has invested heavily in desalination plants for the treatment of sewage effluent to provide non-conventional water resource for agriculture users. So for our projects, we use an embedded system to get an output using smart irrigation and monitoring system. So embedded system offer a way to improve efficiency with precision and by using sensors. The irrigation of farm field is controlled by the embedded system, processing the obtained data and executing the irrigation process effectively. The proposed system is tested using a small-scale embedded system model. There are five benefits of smart irrigation. The first is safe waters, protect water resources, save money, maintain crop quality, and enhance crop yield. There are four objectives that we're going to achieve in our project. That is to design and develop an automatic irrigation and monitoring system controlled by using a microcontroller. Second is to control water pump system. Third is to measure water reservoir level. Fourth is to measure air humidity temperature. Thank you. And the next slide will be presented by my friend. Thank you.
Hi, my name is Aisha Binti Bahrain and my ID number is EC19098. So today I would like to explain about the part of literature review for this project. So model-based irrigation control strategies have been presented in many research papers where complex models incorporating variables such as crop water demand, weather conditions, water saturation, and etc. They are used to get a reliable estimation for the water requirement. This cited from the paper of from the Chagri Serdaroglu in 2020. However, there is still no system that combines both function of the irrigation and temperature to control the air humidity. Hence, in this paper, in this review, there will be a separate section that I would like to explain regarding each of the system. For this irrigation system, in this proposal of the project, they are using 6 sensor to obtain the digital input since the node MCU supports only one analog pin. Then the average is taken into account and water is irrigated as a whole to the entire land or crop area of the interest. As you can see here in this picture, this is the schematic diagram for this proposed project. And this one is the block diagram for the proposed project. So for the processing unit, they are using ESP8266. And then for the relay driver motor, they are using 3.3 volt relay to control the 5 volt submersible pump. And then for the output, they are using control panel and the panel board. For the system of the temperature and humidity, this is the schematic diagram for this temperature and humidity system, where they are using several sensors to obtain the parameters, and then they're using motors for the pumping, fans for the circulation and the control. So the component that are using for the system is ESP32 as the processing unit, and then optocoupler relay, peltier effect for the temperature control, water pump for the soil moisture control, the exhaust fan they're using to remove the high humidity air in the greenhouse, and then they also install the light in case it is required for the plants, and then the last one is the fertilizer pump.
Okay, so for the simulation here, as you can see, there are 6 output devices, which are 3 LED for the pump 1, pump 2, and pump 3, and also 3 water pump, which is the water pump line 1, water pump line 2, and also water pump line 3. And then there are also 4 input device, which is consists of one analog input, the cooling fan here, to measure the voltage of the fan, and then also the button here, the digital input for switch A, switch B, and switch C, which switch A is control the water pump line 1, same with switch B to control water pump line 2, and also the switch C to control the water pump line 3. So let's start the simulation here. So for starting, it will show at the LCD display here, it will show the fan volt, the voltage of the fan, and also the initial condition, which is either the pump stop. And then if we if we press the button switch A, the LCD display will show the pump line 1, and this is it means it's running the pump line 1. So, and switch B also same. If you press switch A, switch B simultaneously, and also it will run the pump 1 and pump 2 simultaneously. So same with the switch C. It also will turn on the LED and turn on the water pump. So if we not press the switch B, then also it will stop the the water pump and also the LED. Same with switch C and switch A.
So for the conclusion, since the increase in the price per increase in the unit power output of a photovoltaic system is actually greater than the diesel and the gasoline or the electric system, so the PV power is more cost competitive when the irrigation system, which is operate has a low total dynamic heat. So for this reason, PV power is more cost competitive when used to the power a micro irrigation system as compared to an overhead sprinkler system. So this PV power for irrigation is a cost competitive with traditional energy sources for small remote application if the total system design and utilization timing are carefully considered and organized to use the solar energy as efficiently as possible. So for the future, when the prices of fossil fuels rise and the economic advantages of a mass production reduce, the peak work cost of the photovoltaic cell or the photovoltaic power will become more cost competitive and more common. Hence, we design a water pump method for an agriculture system. Generally, this water pump is the most commonly used for the agriculture purposes. It is because it is a rotary machine in which an impeller rotates inside a casing, draws in the liquid at its center, and throws out the liquid through an opening at the side of the casing due to centrifugal force. So that's so for the reference, this is the list of reference that we are using in this project. And that's all from us. Thank you.